So they're talking about this firm manufactures widgets. A widget's just an item. We don't have to know what it is. Sells them for $50 each. The costs incurred in the production and sale of the widgets that are $200 plus $10 for each widget produced and sold. So write the following functions for the production of the sales of our radios. All right, so we have to define a few things. We're not going to worry about too much about what this is as it sits, but I want to define a revenue function. And then we'll work through these. So a revenue function, yeah. Oh, thank you. That what you wanted? You couldn't see the screen from where you're sitting? All right, revenue function. Okay, so revenue is found by using this particular equation. So it's going to be, revenue function is the price per unit times the number of units. Okay, so if it costs you $10 to make something and you make 100 of them, 10 times 100, so that would be your revenue. Okay, and then the cost function. The cost function this is the total cost to produce X units or whatever. Okay. And then let's see, fixed costs. What are my fixed costs? I'm losing where my fixed costs are. Even point. Oh, so fixed costs. Fixed. Oh, it just blew up on me. I gotta. Okay, you guys have those written down, I hope. If not, I can rewrite them up. My thing just dorked up because I touched the side of my computer while I tried to write. And it blew it up because I'm recording at the same time, so it doesn't like that. So fixed costs are, so costs are broken into two parts. So fixed costs are like depreciation, rent, utilities, and so on. So if you had a company and you had to pay rent, could be like your rent, your power or your electricity, your water, you know, anything that you would have to definitely, you know, pay each month, things like that. And then you also have the variable cost. The variable cost is directly related, so related to production. So all right, and then the profit function. Let's see, profit function. Where's my profit? All right, so I'm going to write what profit function is first, and then we'll define what each thing is. All right. All right, so that's basically our profit function. So let's see what certain things are. Okay, so this is your revenue from sales. and this is the cost of production. Okay, so if you sold your stuff and you wind up getting $1,000, but it cost you $100 to make, basically your profit's going to be $900. So this C at X here includes these items in there as well. Okay, so just to know that. So MR is called marginal revenue. We'll talk about that. Marginal cost is MC. Marginal profit is MP. It says notes on margins. Not quite sure what that necessarily means in this book, but so if it says, suppose that the cost in dollars to produce is C equals 21.75X plus 4890. What is the marginal cost for this product, and what does it mean? So the marginal cost in this case is going to be the 21.75. So that basically means that's how much you're going to have to pay each time you make the item. Okay, the 4890 becomes kind of your rent, your electricity, all your utilities if you had a building. Okay, so the example down below says, suppose when 1,000 widgets are sold, the company makes $15,500, and when 1,800 widgets are sold, the company makes $27,900. Okay, so I think I have this in my book, so I can walk through it. Where is it, marginal cost? No. Making 1,000 units. Making 1,000 units. Supply demand. All right. I know I have an example in my book that this came from, and I can't find it. All right, so let's just walk through it. We can get through it. So they're making 1,000 non-highlighted things, 1,000 items, widgets, 1,000 widgets are sold. Oh, I changed color without me doing anything. Okay, they're going to make $15,500. This is kind of our profit. When 1,800 widgets are sold. Okay. Okay, so when 1,000 widgets are sold, they make this. And then when they make 18,000, it's this. Okay, so we want to write an equation based on this. So think about this: 1,000, comma 15,500, and then I have 1,800, comma 27,900. So what do those two values kind of look like algebraically? They look like equations, or do they look like points? What do you think?
Points.
Points. All right, so we could go find the slope, use point slope, solve for y, or we could jump onto Desmos. All right, so if I have 2 points on Desmos and I want to find the equation of the line, I'm going to hit our plus button and I make a table. So my first table is 1,000 and 15500. And then my other equation is going to be 1,800, not 18,000, and 27,900. Okay, and if you hit the plus button, it'll show you where the points are. I'll make it a little darker so we can actually see it. So those 2 points. So by geometry standards, if we have exactly 2 points, we can find exactly one line that fits. Does anyone remember how to do a line of best fit on Desmos? Using y equals mx plus b, but what should I use in place of y equals mx plus b? Anyone recall? It's y sub 1. Yeah. Huh? Rather than equal sign, what should I use? Squiggly. It's called tilde. Yeah, it's on the alpha down here at the bottom. Okay. All right. And go back here. And then mx. Oops. There you go. M x sub 1. And then plus b. And lo and behold, that gives you the line of best fit. So our equation to this particular, our actual linear equation is y equals 15.5x plus 0, or 0 is our y-intercept. Don't worry about the residual values or the R correlation values or anything like that. Okay, so that's all we're doing. Okay, so that's pretty simple. So that becomes the equation for that very first example. So y equals 1.5x. Okay. So this is our revenue. R at x is this equation. Okay. Suppose the profit function is linear. The marginal cost is $5, and the profit is $200 when 125 units are sold. Ooh. Can I move off this screen? Or actually, I just expanded. All right. So the second example, they say it's linear. So the marginal costs are $5, and the profit, marginal MNX P to X, it is 200 when 125 units are sold. Come on. All right. So we need to kind of play around with this equation a little bit, which means if I produce 125 units, $200 is made. I have this cost of $5. So if I go back to my profit equation is going to be this, 5x, and then we have to think about this point here. So how would I incur plugging a point in when I basically have all this left? What do you think? Well, the thing is, you have to go to this equation here. If you remember this from Algebra 1, this is called point slope. Okay, so what I'm going to do is this is what I'm going to make. This is how many we had to sell. Okay, so this is going to be y1 and x1 when we use this equation, which gets pretty goofy, but it's all going to go y minus 200. I know that my slope is going to be 5 based on above, and then I'm going to go x minus 125. Come on, there we go. 1.25. Or 125, I don't know why I have a decimal there. And then if we wanted to solve this just to get y by itself, we have to kind of rely on our good old-fashioned Algebra 1 skills, which we all loved Algebra 1. So 5 times x is 5x, and 5 times 125, what do you think? 5, carry the 2, 10, carry the 2. 1, so 625. Add 200 to both sides. So minus 425. So this here is our profit equation. Okay. Huh. So it gets a little wacky when you're doing this kind of stuff. Okay. So there are some things that we are going to work with. Desmos is going to become our best friend when we're dealing with this stuff. So what we're going to be looking at on Desmos, oops, I didn't mean to clear that off, is this. I have some XY axis, and I have two lines that cross each other. We're going to be looking for this intersection. A lot of times this is called the break-even point. So one of these lines would represent your cost to produce, your energy cost, and the other one is going to be like the cost of, or the profits you make. So the profits minus all of your other costs are going to take place in there. So we can go with the graphing unit, which is fine. We can use Desmos, so it's going to be helpful for us. I don't expect you to go graph and try and figure out where they cross, because when we have electronics to do it, let's use the electronics. So let's see. Cool. So it says a manufacturer sells their widgets for $10 per unit. The manufacturer's fixed costs are $1,200 per month. The variable costs are $2.50 per unit. How many units must the manufacturer sell to break even? I don't know why I reduced that again, but we'll go with it. All right. So the first thing we're going to do, so our revenue costs us $10 per unit. That good so far? I hope. And then we know that the fixed costs, I'm just going to put this off to the side, fixed cost are $1,200. So that'd be like our rent and our utilities. So if we were to say that our total cost is going to be the $250 it costs us to make each unit, plus the $1,200 that it costs to have my store open or my manufacturing plant open. Okay? So we're going to call this cost equals 2.50 plus 1,200. And then we want to find the break-even point. Okay. So that means I'm going to take my revenue equation, so I'll make that y equals 10x. And I'm going to take this, which we could just call y equals 250x plus 1,200. So I want to graph both of those on Desmos. Okay, which is going to give us two lines that are going to eventually intersect. We might not see the intersection right away, so we might have to find it on Desmos. All right, so I'll get rid of both these. So I have y equals 10x. And it might show a line there. And then I have y equals 2.50x plus 1,200. Okay, and then go away. So I only see one graph so far. I want to see a red. Oh, there we go. We have a red and a black right there. And then the beautiful thing about Desmos is I can click on that point. So this means our break-even point is 1,600 comma, or 160 comma 1,600. Okay. So that's break even. So things that I want you to see. I'm going to redraw this back on our graph. So we basically any ideas? Let's go to the next screen. This point was 160, comma 1600. So the region over here, this is our profit region. So if we make anything within that region, any of those points is going to give us profit. And over here is our loss. And those are really the only two that we're dealing with. So if I produced here and here, I'm losing money. If I produced here and here, I'm making money. If I produce exactly there, well, let's face it, if I run a company and I produce something and I don't take a loss, but I don't take a profit and I make nothing, I don't know how long you can keep your doors open. Okay? So it says, using the fact that the profit function was found by subtracting the total cost function. That's just telling us how to get to the break-even point. But we can easily do this problem using Desmos. And those regions, the right and left regions, are basically the ones you're looking at. So the furthest right and the furthest left regions, depending upon what your graph looks like. And then the very last example, I will worry about the last example for tomorrow. Deal? So I think if you would like, give worksheet 2.1, problem number 1 a try. Try just number 1. See if you can kind of work through it. I mean, struggle a little through it, and we'll totally go over it tomorrow, okay? Can I borrow your pencil?
Yeah.
Thanks. I just have to remind myself that I assigned my number 1. And we're at 2.7. It's got a little bit less light because it's on my paper. All right.